Our next speaker is a software developer who has a deep focus on DevOps. With over 7 years experience, she's played many different roles, including engineering manager, infrastructure engineer, and security consultant. She's also passionate about building high-performing teams, driving decisions, and coaching others. And outside of work, she loves to de-stress after a long day at work by cooking, and hopes to open her own vegetarian restaurant one day. So if you do find her later, you can ask her what her signature dish might be. Please welcome to the stage Aditi Agarwal.
Hello. Hi. Thank you, Edward. Hello, everyone. I know it's late in the day, so I will not bore you with another deeply technical talk today or go into a lot of complex frameworks. In fact, some of you might even wonder, why is this talk part of a technical conference? So I'm sorry for the geeks that are out there. But genuinely, what I want to share today is going to be relevant for all us technologists, whether you're software engineers, product managers, or even CTO. So Edward told you a little bit about what I do for a living. Let me start off by telling you where I got the motivation for this talk. Why do we have to care about sustainability? So my mom is actually a primary school teacher, and I have attended many of her sessions where she is educating the kids about green behaviors, sustainable behaviors like bring your lunchbox in a cloth bag, write an essay about climate change. And during one such discussions a few years ago, it made me think that what can I do as a technologist to contribute to the world of sustainability and green? So with that, I decided, okay, I'm not going to live under the rock anymore, and I'm going to go and understand what is the role that technology plays in the world of sustainability, climate change, and global warming. Slowly and steadily, I've come to realize that we have a big part to play in sustainability. And today what I want to do is sort of give you a TLDR version of what exists for technologists in the space of sustainability. And my hope really here today is to create some awareness, because it really pains me to see how little people care about it, and even more so as technologists. So let us start with a quick show of hands. Just put your hand up. How many of us worry about cloud and infrastructure costs? Don't be shy, just put your hands up. I, for one, have worked for a lot of clients where we have optimized their cloud costs. Thank you for that. That's around maybe like 30 to 40% of the room here. Next, how many of us worry about carbon emissions from the systems we build? Anyone in the room? Okay, we have a few. Awesome. So I hope that what I will cover in the next few minutes will give you an idea of what we as technologists can do. So let me start off by asking this. If you had to guess which country contributes the highest number of CO2 emissions, what would your guess be? Like, take a wild guess. US? Okay. Yeah, that's on the list, but it's not the largest. The largest is actually one of the most advanced and most populated countries, China, followed by the US and India. Now let's for a second imagine if internet were a country. Where do you think on the list it would be? Actually, internet is the 7th largest contributor of carbon emissions, if we are just measuring by the size of emissions, right? Similarly, like whenever you talk about sustainability or climate change, like aviation industry comes into talk a lot. Like I'm sure everyone here has taken a flight, and if you now go to your typical tools like Skyscanner, Google Flights, they will indicate to you like this flight is probably emitting less carbon. But what I was surprised to find out is that actually 3 to 3.6% of carbon emissions come from the tech industry, and that is at par with the aviation industry. So with that, I hope I have convinced you that our generation is facing what we call a green technology challenge. There is often an assumption or a myth, I would say, that going digital is necessarily more environmentally stable, although that may not always be the case. So let me tell you a few more numbers. Firstly, internet is responsible for 10% of the global electricity consumption. Secondly, our data centers, where we run all our applications, consume around 2% of the world's electricity. Thirdly, leaving a browser tab open, which we all are guilty of, long enough can actually consume more energy than a physical newspaper. And lastly, improvement to the design of YouTube, and this might be older data, I hope they have improved by now, but improvement to the design of YouTube, and by that, our systems, we can actually save carbon footprint as high as 50,000 cars globally. So with that, I hope that you have agreed that you and I have a part to play in this. Like, mind you, I've not even gone to the crypto side of things. So if there are any crypto enthusiasts in the crowd today, firstly, I'm sorry for your losses. Secondly, mining contributes and has a high implication on sustainability. So with that, the good news though, or the positive side to all of this is that we can do something. So today I'll talk a little bit about what is green software engineering. What do we mean when we say that we can build green software? Then I'll talk a little bit about governance around green software, because typically if you can't measure the carbon emissions from your systems, you typically can't reduce them. Thirdly, we'll understand a little bit about how we can organize our teams, because there is a way of sort of a cultural change we need here. And lastly, if I've really got you thinking and you want to dive right in, I'll share some techniques on how to get started. Okay, so let's first start by understanding what is green software engineering. So it sounds fancy, but at a very fundamental level, it's an application that emits less carbon. Now, less is a relative term, and it's comparative, right? Less than what? But just bear with me, because there are ways in which we can measure it. When we talk about how do we make our applications emit less carbon, we typically talk about something known as carbon efficient, which means that there are architectural and software changes we have made from the get-go of the application when I start building to make it more energy efficient, which means using the same amount of energy. So I can do the same workload, but use less amount of energy. So the amount of kilowatt hours that I use will be less. Or I can make it hardware efficient, which is generally related to the optimization of the end user devices, as well as running the same workload, but using less hardware. The other way to think about when you think about emitting less carbon is to make your application carbon aware, which means that you change its runtime behavior. How do we do that? There are two ways for this as well. First is a temporal way. In this, what you do is you basically run your workloads or run your systems when more renewables are on the grid, right? So what that means is in sunny Singapore, you might want to run your more compute-intensive workloads during the day when the sun is shining. Or it could be spatial, which means where you run your workloads. What that means is that if I know data centers in Europe are powered by renewable energy, then I choose a data center in Europe, right? So that's what we mean by the runtime behavior. So I've shared a lot of things here, but what I want you to take away is there are two ways in which you can optimize your application to emit less carbon. One is you change how it's built, which is the architecture and the software changes. And the other one is that you change the runtime behavior. So let's start with the first one, which is how do we make our applications more carbon efficient by designing and architecting them right. So the first section I will talk about how do you architect your application for minimizing carbon. And in this we'll talk about how do you design or think about your microservices, your databases, your performance, your data storage, and so on. So let's start with microservices. I'm sure everyone here has heard of microservices. If you've not, microservices architecture is just a loosely coupled set of building blocks that are modular in nature and then interact with each other through common interfaces. Now, when you are designing your microservices, think about what you can do to make your application or make your microservices green. The first thing you can do is, of course, optimize the network traffic. So the amount of communication that happens between microservices and where this communication is happening. So containerization or Kubernetes, as we know today, is a very powerful tool compared to plain vanilla VMs. Next, you want to think about event-driven architecture. Asynchronous is usually better because there's no idle or waiting time. And secondly, you want to explore serverless. No pre-provisioning of hardware, no long-running services. Serverless is usually better. Thirdly, you want to design your microservices in a way that individual services can be auto-scaled. So you don't want all your applications to have to scale when there is more traffic. So you need to design them that way. And lastly, somewhat controversial, you might also want to revisit the number of microservices. If all your microservices are talking all the time to each other, they are very chatty, then maybe there are things you can do there to consolidate that. So hopefully next time when you think about microservices, these are some of the things that you will stop to think about. So as you can see, the main objective here is to make our application consume less CPU and less network. And indirectly, this means they consume less power, which is less kilowatt hours, and therefore they contribute to lesser carbon. Okay, so now we have designed our microservices. The next thing that usually comes as, even in system design interviews is your database. So when we are talking about databases, typically the rule of thumb is try and think of your query patterns when you choose between SQL as well as no SQL versions. Yes, that's correct. And you would also want to see if that no one database. So for example, you have very SQL intensive queries, but you also have a use case for a NoSQL. It's actually better to store redundant copies in some cases, but use the right kind of query for the right database. Next, something that we learn in database 101, 102, use indexes. Indexes are very powerful. That is the difference between our computer science degree of O1 versus ON. And that can really reduce the amount of CPU the database server needs to use. Next, use optimized query. Typically, not a lot of us do this until we run into a scaling problem. But using optimized queries is good for your business. You get performance, but it's also very good for your planet. And lastly, database caching can reduce certain compute-intensive queries. So you might want to pre-compute some of the data-intensive queries and cache them so that the next time you can fetch them directly. Okay, so now we have discussed a bit about microservices. We have discussed a bit about database. I want to talk about something here which is about performance. How fast does your application need to be? And if I ask this question to my clients, invariably everyone says as fast as it can be. Right? Everybody wants things to be fast. But I would really encourage, if your use case doesn't need it, to rethink what your performance and latency limits are. This is because if you relax some of your latency limits, it can have a big implication on the carbon impact that you create. Again, typically speaking, asynchronous is king. You might want to run most of your not urgent tasks as a worker process later. So what this happens is the same server that is serving user traffic, when the user traffic is low, can use the same CPU capacity to run your worker jobs. So the total amount of CPU that you use is then lower. Okay, so the last thing in the architecture section that I want to touch on is data storage. So again, in this, the rule of thumb is, and again, it's a use case specific decision, so please review this more deeply, but adopting edge computing is a good idea. Why? Because it reduces the network trip time, right? You can move computation as well as storage closer to the source. So one of the very commonly used techniques in this area is to use the JavaScript offline first approach for the workers. What this means is that even before, when the user is accessing data on their phone or they are accessing data on their web, even without making any server request, a lot of data and a lot of insights have already been served to the user. So you don't even have to make the trip to the server. So with that, I have shared some of the techniques of what you should do when you're architecting your application, right? So now you have built in these principles. So the next logical thing is you're now running in production. How can you operationalize your application for minimizing carbon? So again, there are tips and techniques here that you can use to sort of apply that you can minimize the carbon purely by how you operate. So how many of us here have heard of infrastructure sprawl? Anybody? Okay, great, a few. Yeah, I mean, I don't blame you if you've not heard of it because it's typically a problem that you wouldn't have if you are a smaller organization. But typically as the users grow, as the number of business requirements grow, you would see that infrastructure starts getting provisioned for almost every use case, right? And once you have automated it, that's it. But what infrastructure sprawl tells us is that when you are growing fast and you're growing big, there could be an option of a lot of underutilized or unutilized infra resources. So as part of managing your infrastructure sprawl, you should also try to remediate these resources and basically get rid of them. Next, when you're operationalizing, again, a slightly controversial topic, I would say, is think about your test environment. Like I've worked for clients where there are 5, 6 test environments before production, SIT, dev, QA, pre-QA, post-QA, I don't know, right? Like so many. So you might, I'm not saying you don't need them, but you want to think about why you need them. Because each new test environment contributes to that much carbon into the atmosphere. Do pragmatic testing. Test where it makes sense to test. Don't test library code. The library owner has tested it. Shift left, like try and run most of your tests on infrastructure without having to provision a lot of infrastructure. Understand the test pyramid. This is a core software engineering principle we follow at Thoughtworks. Please do not write integration tests for things that can be tested with unit. And think, I urge you to think, this may or may not be something that makes sense in your context, but can you do with one less test environment? Okay, so now we have architected our application right. We are also running in production. And the good news is that we are seeing a lot of traffic, right? We have suddenly expanded, business is doing well, business is happy. So what we see is that our network traffic has started to increase. So at this point, what you want to do is you want to optimize your network traffic. So it's a good problem that you can even make better by not directly sort of expanding your servers and contributing a lot more carbon. So the first thing you can try is to introduce caching. So caching, we all know, it's one of those computer science concepts that you know. So you want to cache static assets so that, again, you reduce the amount of network traffic that your app needs to make. Secondly, CDN, which is the content delivery network. Again, you move the computation and storage closer to where it's going to be used. And lastly, which we have not touched upon quite yet, is decompression and compression. So whenever you are sending data across or in transit, try to always compress it, because smaller amount of data usually takes less carbon to be moving around systems. Okay, so now we have understood how we operationalize, our business has also grown, and now we have managed the network traffic. The good thing that I like about talking about technology and sustainability is that what makes your application green, more often than not, makes it engineering sound as well. So most of the software engineering principles are also sustainable by design. So one of the things you'll realize is that as you adopt more and more green software principles, you will also achieve what your business wants you to do, right? So you will have faster feedback loops, you will meet your delivery timelines because you have just, sort of made your delivery process lean. And how have we done that? So the first one, remove unused feature toggles. How many of you have feature toggles in production right now? Few? Yeah, I mean, I have feature toggles in production that I've not, toggled on or off for months, but they're just there because, we like to have it there. So yeah, just remove them, right? Like if your business doesn't need that toggle anymore, that's just one flow of code that's not being used, just remove it. Next, again, a basic software engineering principle, include your non-functional requirements into your functional requirements. So when you're building the system, think about performance, think about latency and other things. Next, remove dead code and redundant dependencies. Especially when the application grows, I can tell you, a year in the application, there is dead code I can remove, right? So always actively look for dead code that can be removed. And lastly, keep your dependencies updated, because newer versions of software are typically more performant and generally kinder on the planet. Okay, so with that, we have covered what it means to architect to be energy efficient. Next, we'll look into hardware efficiency. There's not a lot here, so don't worry, but whenever we talk about green software, we should look at both the software side and the hardware side. So how many of us here actually still procure our own hardware? Anyone? Okay, great. Okay, we have a few. Okay, great. I mean, I've never done that, so it's surprising to me. But there are things we can even do when we are procuring our hardware to make this process more sustainable. So let's look at that. The clicker was going to fail me. Okay, so every year we generate almost 50 million tons of e-waste, right? And that's equivalent of 5,000 Eiffel Towers. So IT organizations, especially the big ones that procure a lot of hardware, have some opportunity here. So the first thing you want to do is factor sustainability into your procurement policy. So what that means is even when you put out the tender to procure hardware, sustainability is a consideration. Like, is this vendor or is this provider sustainable? Secondly, you want to have a shared vocabulary between your vendors. What I mean by that is with more pressure of green technology, a lot of vendors are publishing some emissions from their supply chain. But they are all in different metrics, and it's hard for you to compare, okay, which one is actually truly emitting less carbon. So you want to have a shared vocabulary among your vendors. Next, you can consider refurbishing your IT equipment. What that means is that every time, instead of replacing, you consider refurbishing. And you might want to weigh the trade-offs, because newer hardware is usually more energy efficient. So refurbishing might not always be better. You might have to weigh that trade-off there. And lastly, you want to understand your hardware provider's sustainability goals. And you want to sort of form a strong relationship with them so that you can see the whole supply chain footprint. So in order for you to be able to optimize the hardware efficiency. Okay, so with that, we have covered the architecture and the procurement side. Like, okay, how do I make sure that my application emits less carbon? But that's it. That's all I can do. Now I have to run my business, right? So the next thing we'll talk about is carbon awareness. Like, let's see how we can change the runtime behavior, like I spoke earlier, to sort of contribute lesser carbon. So here is where the spatial side of things come, and spatial means where. So here is where there are two things that you should consider. One is the energy source. So as I hinted earlier, like a lot of data centers in the world are now powered by renewable energy, which means you should look for the energy source where you're running your applications. And secondly, the energy efficiency. So energy efficiency is like your PUE rating, like even our appliances have it. So generally running software on efficient hardware is better. So all our big cloud providers are on this, thank you. So AWS, Azure, GCP, all have committed to 100% sustainable hosting by 2030. So one way you can become sustainable is just by deploying your workloads on the cloud, right? At least on the clouds that are 100% sustainable. However, there's something we need to realize here. AWS is going to ensure the sustainability of the cloud, which means the servers, the cooling, water, etc. But we are still responsible for the apps that we build and we run on AWS or whichever cloud provider. So the second one here is temporal, which means when. So here again, as I shared in the earlier example, you can schedule your workload. So in Singapore, you might want to run in the day. And the other thing that you can consider here is not always on. So I have worked on applications that don't need to be on in off-work hours, that don't need to be on during the weekends, but we have left them on, and that's because we have better things to do maybe. But that is one thing we need to think about, right? Like we should not always, by default, assume that every application, every service, every resource should always be on. Okay, so now that we have understood and made our applications carbon aware and carbon efficient, the next logical question in this journey is, how do I know that I've created significant impact? So we cannot reduce what we cannot measure. So how do I govern whether I am on a constantly improving path and I'm actually reducing my carbon moving forward? So the good news is that other people have thought about this, and they have come up with what is known as a software carbon intensity score. So this is not a whole number. Like, this is not like, this application is contributing this much CO2 into the atmosphere. It's actually a rate. It's actually a score. So if we look into this equation a little bit more, so here we have a E factor. So the E factor is nothing but the energy that is consumed in kilowatt hour, the electricity you need to run your software. And then we multiply that by a factor of I, which is the carbon that is emitted per kilowatt hour of using that energy, right? So this gives you your total CO2 emissions. Then we add a factor of M to it, which is hardware in general emits carbon. So then the factor of that is added to it. But what we do interestingly here is that we divide it by a functional unit. And this ensures that we can keep track of how our software is scaling. So this R represents the number of users you have or the number of devices you have. So what you can understand here is that the SCI, if we did not have the R factor, will keep increasing as my business grows, right? Because I will be using more energy. But the per R factor ensures that at least you're not linearly increasing as you are increasing your customer base. So that's why it's a rate. And this makes it work for every software domain, every use case. So you can actually compare your and mine SCI scores. It makes it a bit more universal. Okay, so now that we know this, now how do I apply it? It looks quite complex. So the good news is that there are tools in the market that help you achieve that. And one such tool is the Cloud Carbon Footprint, CCF. It's an open source tool that allows you to measure, monitor, and reduce your carbon emissions. Shameless plug here, it's built by Thoughtworks, so you do have the quality and all that assurance in, but it is open source, so we are being ethical about it. But the good thing here is that it gives you a trend of your cloud usage over time. And also what you will see is that it gives you a very friendly number that you understand. So like this particular application, and it's just a sample, is emitting CO2 equivalent to 340 direct one-way flights between New York and London, right? So it gives you that number and really, drives that point home that, the amount of carbon you're emitting as part of your application is quite high. Okay, so with that, when you start on this journey, there's one, caution or word of warning that I want to share is, as with everything we do, don't get stuck in the weeds, right? So when you start, you might get very excited. Okay, tomorrow I'm going to remove all my feature toggles. I'm going to remove all the dead code. Next 1 month, I'm going to not have any redundant dependencies. Yeah, that's great. But you want to fight the battles that actually make sense. Right? So here I'll share 2 guidelines with you, and again it's contextual, but typically go after the low-hanging fruits first, like things that don't require a lot of effort. For example, in the infrastructure sprawl scenario, just kill off the unused resources on the underutilized resources. Remove applications that nobody is using, right? Like, so just get to the low-hanging fruits first. And then think about the big ticket items. What do we mean by the big ticket items? Like, for example, if I'm running a workload on a data center that's not powered by renewable sources, and if I simply move this workload to a data center that is powered by renewable sources, I can create a big, big impact on my carbon emission. Right? So you want to go for the low-hanging fruits and the big ticket items and not get stuck in the weeds, optimizing something very basic in your application. Okay, so a lot of you might be thinking here, and there are a lot of naysayers when it comes to sustainability, that okay, this sounds very good on paper, but has anyone even done this? So I want to share 2 such examples of where I have seen this in practice and it has worked very well. The first one is the Ecosia search engine. Has anyone heard or used it before? Okay, there are a few. Okay, great. So Ecosia search engine is one such organization that is trying to offset carbon and try to plant trees for all their advertising revenue. And I have used this for a long time. I think it's now 2.5 years for me. And I can assure you that the first link is still Stack Overflow. So the search engine works for all the queries that we want to make. But it goes a step ahead, and it also educates customers to be more carbon efficient. So how does it do that? So say, for example, on Ecosia, you search for iPhone. Right? And it will give you the usual listings from Amazon, but it will also tag them with refurbished or used. So as a customer, you can make a more informed choice. Right? The next one in this domain is actually Hola Luz. I hope I got the pronunciation right. But this is an energy company in Spain. And this is one of the areas where they applied the CCF, which is the Carbon Cloud Footprint tool that I spoke about earlier. And they were able to reduce their annual infrastructure costs by 3%. Thereby also reducing their CO2 emissions. So these are real examples of where people have seen value by adopting some of the practices that I spoke to you about. Okay, so there was one more thing that I mentioned at the start of my talk, which was around that this is a cultural change, right? Like, you or me cannot just drive this tomorrow. So, but there are ways in which we can think about our teams to also, move a step closer. So how many of you here are part of like platform teams, like teams that are responsible for infrastructure, DevOps, pipelines? Okay. And how many of you work in like functional streams, like streams that deliver business requirements? I'm guessing the rest, right? Okay. Let's go with that. So there are responsibilities even that sit with the functional streams and the platform teams. So platform teams, functional streams, that can adopt certain practices. The first one for stream-aligned teams is that you can, whenever you are architecting your requirements, you're writing that user story, think about how you can address that customer's specific needs, but in a carbon-efficient way. Right? So again, very simple here is, okay, what is the latency that I can actually have for my user, which is carbon efficient and yet works? And the other one is that how can you look for opportunities, like how Ecosia does, to also educate your end users. So these are two areas where your stream-aligned or functional teams can work. I think platform teams is a bit more obvious. So platform teams can think about technical optimization, right? Like, so if I as a member of the platform team are going to deploy VMs, I can instead think about deploying Kubernetes and containers because general utilization is better. And lastly, they can also provide tooling such as CCF or any other way for us to measure our carbon emissions so that each of the functional teams can then adopt it. So that's pretty much the things that I wanted to cover when it comes about, what is green software, what exists in this space. But let me talk a little bit about what's in it for you. As I say, there are a lot of naysayers when it comes to, global warming, climate change in general. But if this sounds like a corporate initiative to you, I really urge you to think again, look through the data again, and know that this is a real problem. But the good news is, as I said, like there's a strong business case. There is direct benefit for you to actually adopt these green practices. Firstly, most of the organizations today have sustainability goals. So if you as a software engineer can contribute to that, that's great. The biggest thing that makes it easy to talk about sustainability is the practices that lead to a greener software are also generally cost efficient. So you can get cost savings as well. Thirdly, brand. Like I was reading one article where it says that in a decade's time, your stock price will be directly influenced by your sustainability initiatives of your organization. So you can start early. And lastly, in tech or in general, there is always talent is hard, and that's because you need to give people purpose, autonomy, mastery to be able to keep them with you. And one way in which you can give them a purpose or a mission is by also making sure that their work translates into good things for the environment. So if I have convinced you and you want to get started, let me share some tools and techniques. But there is one thing that I want to share, that this, as I've said before, is a cultural change. And this is one vision that I firmly agree with, that we as an organization and as technologists have to change the culture with which we build our software today. Like sustainability has to become a core part of how we design our applications, just like performance, security, and so on. So here are certain sensible defaults that I would like to share, and I call them the green sensible defaults. So here is a QR code that you can scan to get to the green cloud checklist. So a lot of what I have covered today is part of this checklist. So the next time you're designing your software or you're thinking about, redesigning your application, take a look at that, see if you can actually do some of the parts of the checklist. The second one is treat green software or sustainability as a CFR. So just like how we want to build security in our DNA, start with security, we might also want to think about sustainability in the similar manner. Next, as I said, what you can't measure, you can't reduce. So at least if you cannot do anything, start by observing. Like just measure your carbon emissions. Just know the kind of impact you're creating. And lastly, a bit controversial, but I'll still put it there, is that at least have 50% CPU utilization. Again, it's case by case, but I have just seen so many applications that don't even reach 20% CPU utilization, right? Like you can do better than that. So the green software landscape is actually growing. The Green Software Foundation, whose vision I shared earlier, is a key contributor to this. But these are currently the tools that exist in this landscape. So all the major cloud providers, Microsoft, Google, AWS, do have their own cloud carbon footprint tools as well, which you can just hook into your infrastructure and measure the amount of carbon. And then there are a few others here. Okay, so with that, I have actually come to the end of my presentation. Thank you so much for your time today. I'll be here for any questions, or if you have explored any of these practices, I'll be more than happy to hear about that. Thank you.